In this video, we will look at the difference between real and virtual images produced by a convex lens, and we'll also look at how to draw additional rays in a ray diagram, rays that are not one of the three principal rays. So here we have our object, convex lens, and the optical axis. In addition to those items, we've also labeled the virtual side, which is defined to be whichever side the object appears on. And over here, the opposite side of the lens from where the object is, we define to be the real side. If an image shows up on this side of the lens, the opposite side of where the object is, we call that a real image. If the image appears on the same side as the object, we refer to that as a virtual image. Let's look at the ray diagrams that you just drew on your own. So here is our object placed at 1.5 times the focal distance. We have our three principal rays leaving the tip of the object that together meet at the tip of our image. Drawing in the rays for the bottom of our object, we locate the bottom of our image. Notice that our third principal ray here actually strikes below where the lens is shown to end. Obviously, in reality, if the lens stops here, then this ray would just keep traveling in a straight line. It's not going to bend in midair. But the ray diagram is really just a tool for us to locate the image. So when we're drawing a ray diagram, we really pretend that the lens is as big as we need it to be so that each of the principal rays strikes the lens in principle and bends accordingly. So that's what we're showing happening here. We're imagining that the lens really did extend down to that point. So that was the first diagram that you drew. Here's the second diagram for the object placed at the focal point. In this case, we can't draw the third principal ray because our object is at the focal point, but we can draw the first two. Principal ray 1 in parallel out through the focal point on the far side of the lens. Principal ray 2 directly through the center of the lens with no bending. And these two rays are parallel, meaning that they will never meet. They don't converge and meet anywhere over here, and they don't diverge, allowing us to draw them backwards to meet anywhere over here. In this case, there is no image formed. If you place the object at the focal point of a convex lens, then there is no image formed. No matter where you place a screen over here, you will always get just a blurry, bright region on the screen. You will never get a crisp image. Looking at the third case that you drew, an object placed at half the focal distance, we draw in the first two principal rays, and we see that these rays are diverging, and anytime rays are diverging, we always have the same rule, and that is to trace those rays backwards. So that's what we do in the dashed lines here, and we find that traced backwards, the red and blue principal rays do intersect. I've also drawn here the third principal ray. Rather than leaving the object and passing through the focal point, this ray is drawn leaving the object such that if we trace it back, it would intersect the focal point, where this principal ray hits the lens, or where the lens would be if it were tall enough. It would come out straight, and we trace that back to find it intersecting with the first two principal rays. This marks the top of our image. Drawing our principal rays from the bottom of our object, we locate the bottom of our image. In this case, the image is on the same side of the lens as our object, so this is an example of a virtual image. Going back to our first diagram here, I have three principal rays from the top of our object drawn. Once we locate the image, it is actually true that every ray leaving the tip of our object, no matter what path it follows, will come out of the lens and intersect at this one point. It will intersect at the image location. So once we use the principal rays to locate our image, once we use principal rays that have simple rules for how to draw them, we can locate our image. Once we know where our image is, we can draw in as many additional rays as we want, knowing that every ray that passes through the lens leaving the tip of our object will intersect at the tip of our image. That's what it means to have a focused image, to have all of the light rays from a single point on your object converging at that location. Going to the going to the virtual image case, in this case, anywhere I put a screen over here, I will get a blurry image. And it will be blurry because, say I place the screen at this location, well, the tip of the image will show up here, but there will also be a tip of the image here, and several places in between from light rays that aren't drawn. Anywhere I place a screen over here, I'm just going to get a big blurry region. In order to see this virtual image, I need to make the light rays from this image go into my eye. My eye can then focus those light rays to give me something crisp that I can see. So here I've drawn a person looking through the lens, and I show one of the light rays going into the person's eye. You might argue that the other light rays don't go into the eye, and so this person doesn't actually see a full image. But just as on the last slide, we drew in additional light rays once we had located the image, we can do that same thing here. So here I'm drawing in the original red principal ray, and I've added a second light ray that is not principal. But once I've located my image, I'm able to draw in this light ray, and I can see two diverging light rays entering the eye, both appearing to come from this location, the tip of the image. And we know that anytime light rays enter our eye, when we look at an object, those light rays are diverging, often from diffuse reflection. So this is a case where we would expect these light rays to focus on our retina, allowing us to see the tip of our image. I can also draw some light rays from the base of our object that would pass through the lens and also make it into our eye, allowing us to also be seeing the base of our image. So this is how we would see a virtual image.